can see me on the mountain if you're ever on Whistler. So I wanted to start by kind of taking a look at what we had before React and when things kind of started and how shitty it was, so you guys can appreciate how good we have it now with the web. And I'll remind, so some of you on that slide have been working with React for a long time, some of you less, but some of you will recognize some of the names that I'll mention. So after that, I just wanted to take a look at the history of React. I wanted to take a look at some of the lessons we learned and kind of a wish list for the future. There's still some things that kind of suck right now, unfortunately. So before React, way in the prehistoric ages, we had something called jQuery. Hopefully you guys don't see that name anymore out there. Some of you may. So jQuery was pretty much a library to abstract the DOM API, which was really bad because Microsoft was in that space. So it was really bad before. And I remember IE6. Hopefully none of you does. So it was really bad. So we needed a way to kind of structure our apps a little bit better. Apps started to grow. We had a bunch of models. We had a bunch of relationships. And Backbone came to the scene as kind of a backbone for your application. It just had a bunch of views, a bunch of templates, and you kind of glued the whole thing together. It was still kind of crappy. We used templates. Then something in 2010, we came out with Knockout.js. So Knockout was the first time we got two-way binding between our view and our model. So every time we change something in the model, then it will change in the view and vice versa. So that worked really well. And there's a bunch of libraries like Angular and Amber that came out of that effort after that and kind of copied the same idea. And finally, React came out in 2013 and said, hey, this two-way data binding you guys are doing, it sucks. We don't want to do it. It complicates our code. It creates a bidirectional dependency. And I think we can do better. So it came out of really, not a lot of people may know this, depending how long you've been using React, but the first time I've seen it was when Pete Hunt demoed it at, I think it was JSConf EU, and he was talking about how it came out from the Doom engine. They had a virtual world in Doom, and then they applied changes to that virtual world, and it gets rendered in the real physical world, in the game. Physical world, that is. So, and you can actually pop out and open Doom 3. It's open source. So you can kind of see some of that yourself if you want. And what I really liked about it is it was based on some good computer science principles. I'll be honest, I thought it was kind of weird when I first started with it. It was like adding the view back into your business logic. It looked really weird to couple your view with JavaScript at the same time. But I kind of liked it after a while that we have JavaScript available to us and we can do everything that we can do with the state, and it's managed very clearly. So it has a very clear definition of what's going on, very clear separation. And my favorite thing, I think, is the composability of React. So you can create your components, you can compose them into subcomponents, and you don't need anything like, so in those guys, you had things like regions, you had special layouts, you put holes in your app. It really sucks. So you don't need to learn anything here. It's just compose your views. And it goes back to really simple principles that we already learned in computer science, where things like hardware already does that. So things like pushing down a buffer to an LED array is something we actually do, and then the driver renders the different lights on the LED array. And that's how we can keep a consistent frame rate in the LED array. So it was a great way to keep a consistent frame rate and get a better experience from a user perspective. Again, the unidirectional flow was really good. After you debug a few of those problems with the bidirectional, you learn the value of what they're talking about. You may not appreciate it if you've never had to do it, but it really sucks to spend half your day trying to chase down a bug like that. So in 2014, we came out with something called Flux. So it was a good way for us to create a global state management for your entire tree. And the way I saw it was more for refactoring of a lot of your React state up into a global scope. So you can put it in your Flux store, and you can call actions on it, and you update the state, and all the components get updated. So Facebook gave us some guidelines, but really didn't do it a lot. So they gave us a simple project, and there's a bunch of different libraries that kind of implemented it whichever way they wanted. So if you started with Flux in 2014, you might have been using one of like 6 libraries, I think, at that time. Luckily, one of them was Redux by Dan Abramov. So Dan created Redux, and it was inspired by Elm. It had a lot of, again, really, really good computer science principles behind it, which I think what actually made it stick. Also, functional programming was kind of on the rise in those years, so that helped with that too. Again, Redux was really, really simple. You have one store instead of here. They didn't specify how many stores you have, so you could have had 10 stores if you wanted to. And that's what we had in early projects. We had one store per collection, per model. And then you had to wait for another store. It was really terrible when you had relationships in there. So this came out, again, composable. You can just create your own root, and you go down, and you always call the reducers in Redux. So I'm curious, actually, how many of you guys are using Redux right now? Awesome. How many of you guys are using GraphQL? Okay. A few. Cool. So, let's see. So after that, we had something really, really nice, which is the Create React app. So before that point, there's no real good standard way of creating your React app. You could use Browserify, you can use Webpack, and spending 3 days configuring Webpack was not a good time. And even less so if you have clients and you have to tell them, hey, I spent 3 days configuring, and they're like, what the fuck? So this came out, you can now use it. It just gives you Webpack. It gives you a testing framework, which is really, really nice. So again, before that point, testing kind of didn't exist. So you had to kind of do a lot of work to set up Mocha, to set up Karma Runner, and all that stuff. It's still not great, but it's a lot better. ES6 is there, obviously. Nobody wants to use ES5. And ESLint is kind of there. What I discovered actually when I ran Create React project just 2 days ago was that it still has semicolons. So you got to change that. Don't like semicolons. In 2017, so we started seeing a lot of companies gravitate towards static typing and gravitate towards GraphQL to try to solve some of the problems with Redux and with consuming data from the API. A lot of those issues were, read a really, really interesting article about TypeScript and should you use it, should you not use it. So I actually like TypeScript, and I started playing around with it and using it. I haven't used it too much, so I don't have a firm opinion on it, but I'll tell you this. So the real problem we're trying to solve with TypeScript is we want to reduce the number of defects or bugs that we have in our code. But the problem with statically typed languages that nobody tells you is that you start becoming overconfident in the type system and the type checking. And you still have a lot of bugs. So there's a really nice article about the number of bugs discovered on GitHub repos and statically typed versus dynamically typed. And Java actually had 68% bugs. Should have probably brought this up here. So it has 68% bugs, where something like JavaScript only had 28%. So it's a big difference in the number of defects. Mind you that JavaScript code bases are also smaller usually, so that may have something to do with that. But testing is kind of important. So yeah, the other thing people started using is GraphQL to make your API light, and it was kind of a replacement for REST. So we're still kind of figuring out what the right patterns in GraphQL. So I expect GraphQL to pick up in 2018 a little bit more, TypeScript, and we'll see a lot more of that. So the next thing I did was I wanted to kind of switch gears and take a look at what Create React App does. Is it really zero config? So I mentioned that you still need to remove the semicolons. You still need to add your React router. So you still need to add your React router. You need to add your ESLint config. You need to add Redux. You need to read a bunch of readmes, and I'll talk about some more. But going back is the apps that we want to build now are a lot more complicated than what we get from Create React App, unfortunately. And that's some of the things that I wish was a little bit better. So generally, and you'll learn that quite quickly, is you want to build single-page applications. Right now, some of the tutorials and what React can be used for is multi-page applications, so you can just load it up onto a WordPress site if you wish. You probably shouldn't be using WordPress. You want to use that responsive interface. You want it to be really easy for another developer to just join your project and have a bunch of conventions and just follow them. So I'm really looking forward to the next talk about Rematch and learning about that. And you want to be able to add other platforms to it, like React Native, and you don't want bugs. So that's probably the biggest thing that I think we should focus on in the next year or so. So what else is missing? So the next thing you need to do after you create React app is you need to figure out, you want to remove the CSS from there. So CSS is kind of great in a lot of ways for marketing pages. It's not that great when you want to work with React because CSS usually encompasses state and you don't have access to that state in JavaScript, and it kind of goes against React. So the more React you write, the more you'll realize that you don't want to necessarily use a hover state. You don't want to necessarily create classes called active, deleted, whatever, and assign those classes. You want to actually do it in JavaScript and manage the state in your Redux store. So to do that, there's two ways pretty much you can do that. One is with inline styles. So inline styles are great. They work well, but they do make your DOM a little bit heavy. There are better approaches now, like JSS, so it's JavaScript style sheets. So it's exactly what it sounds like. It compiles JavaScript into different style sheets and assigns a class to your component. So it's really nice to work with. Another one is styled components that lets you write CSS right above your view there. So both of them work really well. I like JSS a little bit better. And the reason is Material UI uses JSS inside, so the next version of Material UI. If you haven't checked it out, you should. It's really, really great code base, a lot to learn from there, and end up reading it a bunch. So the next thing you would want to do probably is you want to add something like Material UI, you want to add Bootstrap. I would probably recommend that you try Material UI just because it was built from the ground up to work with React. The Bootstrap libraries out there right now are kind of wrappers around Bootstrap, so it's not the greatest thing to work with. So the next thing we want to think about, and this is something I probably didn't appreciate enough when I started working with Redux, so now looking back is something I really, really appreciate, is that you really want your Redux stores to reflect your backend tables, collections, whatever you use on your backend. You want as much of a one-to-one mapping as possible. It'll make it really easy to talk about things, especially with the backend developer. It'll make it really obvious what endpoint to use, whether they're GraphQL or REST endpoints. So the closer you keep the two, the better experience you'll have as a developer. So I violated this rule actually on one of our projects, and I wanted to make make our client a little bit simpler. That was a bad idea. And where you will start doing that, so for example, in this case, I have a user, I have post, and I have comments. But imagine I had a multi-tenant application that's kind of like WordPress, a clone of WordPress. So we have multiple blogs, and different people can have posts in there. So you'll have this blog object there that represents the person who owns the blog. And then they'll have users, they'll have posts, they'll have comments in there. On the front end of your application, you don't really care necessarily about the blog. You care about the users, the posts, and the comments because you want to show that. So maybe you don't need it there. But if you start removing that, and then there's a lot of relationship to the blog, you start doing really hacky things, and that's a mistake that I pretty much did in a different way. The other thing I didn't appreciate is that you really want your data to be, your responses to be normalized. You really don't want to get responses that are nested. It kind of goes against what Redux recommends anyway. But where you hit problems is updating the state. So when you have a new comment that arrives, you might have to update it in a few places if you have a nested structure. So the user might have posts, might have comments in there. A post might have comments in there. So depending how you load it, you might have two structures with nested resources in there. So keep it normalized and denormalize it kind of in the view layer, if you will. So I'll show you how to do it in the selectors. So this is something we learned when working with Redux again. So typically we use maps instead of using arrays inside of our different React states, a subtree. And that's just so we can access it really quickly and not have to go do find every time and look for that ID there. So again, it shows you a denormalized state there. So you see how posts have items, and an item has a comment ID 1, 1, 2, 3, and 4, and it references the comments. That's kind of how you want to structure your Redux state. Another thing is that you don't have to have a lot of boilerplates. Just use good computer science principle, just refactor things. So I kind of wanted to finish this library before tonight, but I've been kind of busy, so sorry guys. It is posted, but it's not usable, unfortunately. So what we use is this library called Fetch Redux CRUD. It's based on another library called Redux CRUD that defines a bunch of actions and reducers for your REST communication with your backend, pretty much. And you can just write really nice code like this. So dispatch, fetch users, and you can give it a path if you need. And then this is all my reducers right here. So I just have reducers for users, and it writes all the reducers that I need to fetch the user, create the user, update the user, and destroy the user. So really simple. And then if I wanted to, I can extend it, and I can override some of the actions to do something more fancy in there as well. So inside, so the selectors. So we use selectors, and we usually try to develop some naming convention around them. And a lot of the naming convention come from Rails and how Rails does things. So we have get users, which gets us an array of all the users. And we use it actually inside of our containers in Redux. So really easy. The reason we don't like to store the selector near the reducers, like Dan Abramov recommends, is that those relationships. So what if I wanted to get the user and all the comments inside of that user to pass into my my view to render something like this, right? So in here I have a post object with a bunch of data in it, like who the author was, the number of comments, and that's a nested data structure. So this is a good place to put them inside of selectors, users. I'll fetch a denormalized users state. In this case, I'm just showing you how to fetch a really simple one here. And then we have get user by ID, which we can actually get the user by the ID using just a hash reference there. So really simple. So again, you denormalize the state inside of your selectors or in your views if you want, right before you pass it down to React. You want to minimize the state of your container, the number of your containers. Actually, so you want as many dumb components as you can. So you want to do it in as few places as possible, and that's kind of why you want to denormalize it. So what I mean by that is that you want to have as few containers as possible to describe this UI here. So we can describe it with probably just 2 containers here, or even 1 container for the list, and then pass down a nested object to our tree of components. So some other tips for using your APIs is that to always go through a single endpoint. So you can replace, so if you come up with different API conventions, if you want to add security, authentication, anything you want to add, you only have one place to replace it with. Take a look at this library called Redux Thread. It'll help dry up your Redux stores. Yeah, use some naming convention. And one of my favorite things about React 16 is this thing called error boundaries. So how many of you guys have heard of error boundaries and know what they are? That's just a few of you. So pretty much error boundaries allows you to put a kind of a try and catch block on your React tree. And if something that you don't expect happens, then you can render a page that says, hey, or you can render a small component that says, oops, something went wrong here, instead of crashing your entire React tree and causing the user to have to refresh the page. So I'm sure you've had those problems with production. They suck. So that's something we've been talking about for a while. Kind of glad to see that land in React 16 finally. And your structure of your file structure. So there's a few ways you can structure your files in React and Redux. We like to go by the type of code unit that it is. So actions, reducers, selectors, services, styles, and so on. And then break it down by the feature. So for example, group all the login stuff into one thing, and kind of keep the reusable things in either a shared folder under here. So pretty simple, but it does make it a lot nicer to go into a new code base if you see the structure, and you can just be productive day one. Some of the wish list items is we really lost our ability to do good end-to-end testing with single-page applications. It's really hard, and I haven't seen a good tool yet. And I try every year. I go and explore and try to find end-to-end testing. The only thing that comes up is Angular's protractor, but I don't use Angular. I don't like it, so it kind of sucks for me. So really want to see a good end-to-end testing framework so we can actually write our code and test things like, can the user log in? And hopefully even run that on production, on our production servers to see if we have a problem. I don't want to have to find out from our customers that we have a problem. That's not a good user experience for anybody. The other thing is I would really wish that Create React app gives you an out-of-the-box option to have Redux in there with some kind of a flag. It would be really nice to have some generators to generate some of the code for us, like the reducers, the selectors, the action creators, all that stuff. It takes time to generate, so it would be nice to get some help from our tools. And just overall, as a community, I think we need to do a better job at providing libraries for testing and explaining to people how do you test with this library that I'm using. How do I test requests? If I use X library, how do I mock a request? Do I have some mocks, some stubs, anything that comes with the framework? So, and Rails has all of that in there. So a lot of the Rails jams or Ruby jams have that mentality that to make it really easy for you to test with those jams. And they tell you how to do it. So it would be really nice to see that. And that's about it. So like everybody else, I guess, we're hiring. We're a small team. We love working with cool stuff. And we like augmented reality as well. So if you're bored of web, come talk to me. We'll get you set up with some Swift and augmented reality and some madness. So yeah, so if you guys have any questions, I would love to answer them.
Hey Mike, I'm just wondering if you've looked at WebDriver IO for end-to-end test tool.
I have not.
Okay.
No.
I think you should. It's very similar to Protractor, but less associated with Angular.
WebDriver IO.
Yep.
Oh, take a look. Thank you. Question in the back there.
I'm going to say Cypress is also another alternative.
What's that?
Cypress is also another good alternative.
Cypress.
And
Yep.
for the other, the last wish list that you had on your previous slide, the Cosmos also helps with creating test filters and most like all of the standard React libraries that you use, things like mocking Redux or mocking GraphQL or other things.
Gotcha. So Cosmos, Cypress, and WebDriver? WebIO driver?
WebDriver IO.
WebDriver IO. Okay. Do we have any more time for questions? Guys? Any more questions? Right.
You touched a couple of times on GraphQL, and at one point you also mentioned it's like easier for some things. I'm just wondering why.
Yeah, so I'll prefix it with, so I looked at GraphQL, I read a bunch about it, haven't had a chance to really use it in production, so my knowledge of it may be a bit limited, but some of the problems with GraphQL, and they'll say it right in the documentation, is that how do you update data? There's mutations, but how does it work with Redux? Things like that, they're kind of unclear right now. And also, how do you work with those relationships? I think that's really the Achilles heel of Redux right now, those relationships, and I probably haven't done a good enough job explaining that it is. And if you read some of the documentation, Dan Abramov himself says that, hey, I wish that we had some good examples of using a relational model inside of Redux to show a bunch of relationships, because it's really hard to actually denormalize your data properly and update it properly. It takes a lot of work, a lot of effort to do it properly, and there's not a lot of conventions there. So long story short, GraphQL, from what I tell, is really great at making sure that this doesn't blow up to like 5 megs. So that's great, because your responses, because usually what we do is we just grab the response, we'll shove it in that store, and that's it. So one other thing that I would probably do, regardless of using GraphQL, is I'd only take what you need. So write a transformer to just get the ID, the name, and whatever else you need, and don't use anything else inside of your store. That'll really save you a lot of time debugging things. It'll be just easier to look at your store and not be like, holy shit, what is all this? So GraphQL kind of gives you that for free. That's what it's great for. And the other thing, it's great for backend developers, because you don't need to define several APIs and add extra attributes just for different clients. You just have the clients asking for what they need. So I think GraphQL is great, and I really want to kind of use it more. I'm not sure how it fits in with Redux yet, and nobody has been able to say if it does or how it does from my research so far. So that's my problem with GraphQL right now. All right, cool. All right, thank you guys.